Hey everybody, welcome back. Today we are going to look at the problem set for assignment 9 in intermediate micro. This is looking at problems for monopolies, markets in a monopoly market. We're going to talk about the characteristics of monopoly, and we're going to solve a couple of problems getting to the market quantities, the monopoly price and quantity, and the welfare loss associated with that. So this is for Econ 100B, assignment number 9, and let's get started. Okay, so the first question on the homework assignment, number 1, what are the characteristics of a monopoly? This should be pretty straightforward. The characteristics of a monopoly are 1, barriers to entry, 2, one firm, 3, no close substitutes. That's the big idea there. There's only one firm, there's not a lot of close substitutes, and there's some kind of barrier to entry. The idea here is the barriers to entry prevent other firms from coming in and competing. The no close substitutes means even if there are firms in similar markets, it's just not the same, and that helps the monopolist keep their market power. The bigger those barriers to entry, the greater the differentiation of products, the more powerful the monopoly market is. The more market power the monopoly is going to have. The other characteristics of a monopoly, there's no supply curve. There's only one firm. So if you look at the monopolist, they're going to have the same characteristics as any other market with respect to having a marginal cost curve that looks like that, and in most cases an average cost curve that looks like that. But for a monopoly, because there's only one firm, there we go, lowercase q equals uppercase q, because the firm quantity is the whole market quantity, and there's no supply curve because the marginal cost curve is the total market supply. Hopefully that makes sense. Remember, the marginal cost curve is an individual firm supply curve. The marginal cost curve is an individual firm supply curve in every situation. But in any other situation, there are multiple firms. So you have to add up the marginal cost curves of every other firm, even if it's only 2, to get the supply curve. It's only with a monopolist, where there's only one firm, that there is no supply curve, because the marginal cost curve is everything. It has all the information already there. So other characteristics of a monopoly: monopolies tend to have high prices and low quantities because they're going to face that downward sloping demand curve and therefore have a downward sloping marginal cost curve. So if we have our monopolist here, they're going to face the market demand. They get to act like a monopolist because they are. And so they don't take the price. They see all of our willingnesses to pay. And that means they're going to face marginal revenue. So they're going to tend to have lower quantities than perfect competition would have, and higher prices because they're going to charge prices based on demand. They're going to tend to earn economic profits, which you can see. I need another color. Which you can see right here. If this is marginal cost, this is average cost. These are the firm's economic profits. Above average cost and below price in at the quantity that's determined by marginal revenue equal to marginal cost. Other characteristics of a monopoly, that's the main thing. They have high price. Welfare loss. They're going to generate a welfare loss. They're going to generate a deadweight loss. And the deadweight loss is going to be equivalent to this triangle here, represented by the difference between the monopolist quantity, the monopolist price, and what we would consider the perfect competition quantity and price, which is where marginal cost crosses the demand curve, which is going to be a lower price and higher quantity. So monopolists, one firm, barriers to entry, no good or close substitutes. That's going to mean that they're going to have market power. They're going to face a downward sloping demand curve and a downward sloping marginal revenue curve. That also means there's going to be no supply curve because there's no other firms to create a supply curve with. They're going to have high prices, low quantities, and a deadweight loss. That seems like a lot, but it all comes from the same place, right? It all comes from the fact that they're the only firm in the market. They have this market power and they can kind of do whatever they want because there's no one else to compete with. Cool. Hopefully that makes sense because now we're going to get into the math of it all. And I'm going to get serious, put my glasses on. So the next problem is what I call like the Big Daddy problem, where we're going to go through and solve almost anything I could think of to solve with a monopolist. So this is like the big, we're going to run out of space. I'm going to probably get another whiteboard problem. So let's get ready. Okay. So we start out with a monopoly market with an inverse demand function of P equals 100 minus 2Q. And we have a cost curve, and we can just put an uppercase Q in there. Cost is a function of the quantity. It's uppercase Q because it's a monopolist, so the market quantity is the firm's quantity. And the cost function is going to be Q squared, which means that marginal cost is going to be the first derivative of that. Sorry, that looks weird. Marginal cost is going to be equal to Q. And then the first one, the first question says to use the cost function to find average cost. So we want to find average cost now. To find average cost is really simple. Average cost is going to be cost divided by quantity, which in this case is Q squared divided by Q, which is going to be just Q. So average cost and marginal cost in this case. Oh, I made a mistake. I already made a mistake. The first derivative of Q squared is 2Q. So marginal cost is 2Q, and then average cost is going to be just Q. Sorry, I hope that's not confusing. So each additional cost is going to be 2Q, and the average cost is going to be Q. So that's part A. Part B asks you to find the marginal revenue curve. The marginal revenue curve we spent a lot of time finding in a lot of different chapters. The formula that we use for finding the marginal revenue curve is that marginal revenue is equal to P plus change in P over, oops, I said it, but I didn't do it right. Change in P over change in Q times Q. We're going to see that marginal revenue then is, we're going to insert the inverse demand function in here. So let's change this color and make it a better color. Our red is kind of hard to see on the screen. Here we go. Marginal revenue equals the inverse demand function, 100 minus 2Q, plus this coefficient on our inverse demand function, -2, is the change in P over the change in Q. So we'll put that in there, and then Q. So that gives us a marginal revenue curve of 100 minus 2Q plus -2 times Q, which is going to be -4Q. And that's consistent with what we see. With a marginal revenue curve, it's basically take the inverse demand function and double the slope because it's going to have twice the slope of the demand curve. So now we can put this up here with our sort of saved equations. Marginal revenue equals 100 minus 4Q. So far, so good? All right. So that's part B. We're burning through it. Part B says also determine the profit maximizing quantity the monopolist will produce and the price they will charge. We're getting right into it. So to find the profit maximizing quantity, we want to set marginal revenue equal to marginal cost. That is always what a profit maximizing firm is going to do. I don't know if y'all can see that very well. I'll try and switch to blue. Maybe that one shows up better. Okay. Does that show up better? That totally shows up a little bit better. Okay. There we go. Okay. So marginal revenue equal to marginal cost. We're going to use our marginal revenue curve, 100 minus 4Q and set it equal to our marginal cost, which is 2Q. So that means we're going to add 4Q to each side. That's going to give us 100 equals 6Q, and then divide both sides by 6, which is going to give us our the equilibrium quantity of 16.6 repeating, or 6.7 as our Q. So that is our profit max Q for our monopolist, 16.67. Is that visible enough, or should I make it black? Maybe I'll make it black. Let's do that. Make it pop, right? So Q star for the monopolist is 16.67. And just as a general rule, in pretty much anything, you don't need to go past 2 decimals for almost anything. I had an econometrics professor who used to always say anything more than 2 decimals and you're implying more certainty than you actually have. And I like that. So that's our profit maximizing quantity. Now we want to find the price. So we put this quantity back into the inverse demand function to get the price. So P equals 100 minus 2Q, where Q is 16.67. And so now what we'll do is get 100 minus 2 times 16.67. 2 times 16.67 is 33.34, which gives us a price of 66.67, or let's call it 66.7 approximately. So that is our monopolist equilibrium price. Okay, so let's pop that up here. So that's our equilibrium conditions there for our monopolist. Okay, next part of the homework asks, oops, I lost it there. To graph the demand curve, marginal revenue curve, average cost curve, marginal cost curve, and indicate the equilibrium price and quantity. For that, I'm going to get another whiteboard. Hold on. Okay, here we go. And that way we can go back to our calculations, back and forth between our calculations and our graphs seamlessly. Okay, so we want to graph marginal cost, average cost, demand, and marginal revenue. So let's start in price and quantity space. Oops. And if we remember, our inverse demand function was P equals 100 minus 2Q, right? Our marginal revenue curve was 100 minus 4Q, and our marginal cost curve is 2Q, and our average cost curve was just Q. So those are the 4 curves that we want to graph. And so the first thing we want to do is find out where these curves come from, what their slopes are, what they're going to look like. For the demand curve, we want to find what if Q is equal to 0, then it's going to be P equals 100 minus 2 times 0, or P equals 100. So when Q is 0, P is 100. Same is going to be true for the marginal revenue curve. If Q is 100, marginal revenue is going to be equal to 100 minus 4. And that makes sense. The marginal revenue curve and the demand curve come out of that same point on the price line. The difference is the slopes. The slope of the demand curve is going to be -2. The slope of the marginal revenue curve is going to be -4. So we can also find out where the demand curve crosses the quantity line, we want to find out at what quantity is P equal to 0. So let's set now P equal to 0. So that's going to give us 0 equals 100 minus 2Q. 2Q equals 100. Q equals 50. So when P is 0, Q is going to be 50. Let's put that right here. All right. I don't want to keep this stuff because it's going to confuse our graph. So I'll get rid of that. But now I have a demand curve. Cool? Kind of see that? Okay. Let's make the D really pop. I said that. Okay. Now we want to do the marginal revenue curve. Marginal revenue curve is going to have twice the slope of the demand curve. When P is 0, we want to see what it's going to cross at. Spoiler alert, it's going to be 25. So it's going to have twice the slope. It's going to be 100. It's going to be 0 equals 100 minus 4Q. 4Q equals 100. Q equals 25. So that's going to be right about here. And so that'll be our marginal revenue curve. Okay. Okay. Moving along, now we want to do average variable cost and marginal cost. Average cost is going to be a line out of the origin. And that's because when we calculate average cost is equal to Q. So if Q is 1, average cost is 1. If Q is 25, average cost is 25. So it's going to be a 45-degree angle line out of the origin. That's our average cost curve. Marginal cost is going to have twice the slope because it's going to be Q, marginal cost equals 2Q. So if Q is 25, then price or marginal cost is going to be 50. If Q is 50, marginal cost is going to be 100. It's going to look something like this. Okay? And then we know what our points are. We've calculated them, right? We have them right here. We have our equilibrium point where marginal cost is equal to marginal revenue and the price and the demand curve. So let's put those in. So our equilibrium point where price is equal to marginal cost, marginal revenue is equal to marginal cost at 16.67. The price is going to be based on the demand curve, and that's going to be 66.67. And we could go further. We could figure out what marginal cost is at this point. It's going to be 16.67 times 2, or 33.67. If you like measuring things in thirds, then that might be easier at this point, right? So that gives us a lot to work with. Okay, so now we have graphed the demand curve, the marginal revenue curve, average cost curve, marginal cost curve, and indicated the equilibrium price and quantity. Next step, determine the competitive price and quantity for this market. Competitive price and quantity are going to come from demand equal to marginal cost. So let's go back to our equations and do that. See, I told you it'd be worth it. To get the competitive, let's do it in another color, price and competitive quantity, we want to set marginal cost equal to demand. Marginal cost is 2Q. Demand is 100 minus 2Q. So we're going to add 2Q over here. We're going to get 4Q equals 100. We're going to get Q equals 25. So that's our competitive quantity. And then we insert that into this to get our price. So price equals 100 minus 2Q, which is going to be 100 minus 2 times 25 is 50, equals 50. So what's our competitive price? Our competitive price is going to be $50, and our competitive quantity is going to be 25 units. Cool? Does that make sense? Kinda? Okay. So let's put that up. So now we have Q star for the competitive market is 25, and Q star, or not Q star, P star for the competitive market is $50. Okay. As my dad would say, now we're cooking with gas. I want to graph it because I feel like it is useful. Okay. So what you should get is that's our competitive equilibrium, where marginal cost is equal to demand. It's going to be $50 and 25 units. Cool? So far, so good. The next part is a little bit trickier. Now I say, calculate the welfare loss associated with the monopoly in this market. And the welfare loss in this situation is the difference between the competitive equilibrium and the monopolist equilibrium. And so what we have here is a triangle that represents that welfare loss. And that triangle is the deadweight loss associated with reduced economic activity from a monopoly. So we need to find the area of that triangle. I'm going to erase it because I like my graph, even though I've already mucked it up a little bit. But that's what we're going to find. And so what we need to find is the area of a triangle that has a base that runs from $67.66 down to $33.67, and a height that goes from $16.67 to $25. That's the triangle we're trying to find the area of. And if you need a visualization, it's this triangle here that goes from 66.67 to 33.67 and to 25 from 16.67. This pen is dead. But hopefully that gives you a sense of what we're talking about. So, the area of a triangle, there we go. Is 1/2 base times height. The base of the triangle, let's get rid of this. Now we've got new stuff to calculate. The base of the triangle is, and it really doesn't matter the order you do this in, but I like to make my triangles have a long base because that's just the person I am. It's going to be 66 minus 33, which is going to give us a base of 33. And the height is going to be from 25 minus 16, just this area here, just that height. So 25 minus 16.67, which gives us a height of 8.33. So now 1/2 of base times height gives us an area of a triangle of approximately $137.45 of deadweight loss. Pretty exciting, right? All right, so I'll add this up here to our answers selection. So now we're going to say that the deadweight loss equals $137.45. Cool? All right. Now we want to calculate the monopoly profits. I'm going to use the graph to do the same thing, but we can think about it two different ways. The one thing you can think is that profits are going to be equal to total revenue minus total cost, which is going to be equal to marginal revenue times quantity minus, or sorry, not marginal revenue times quantity. That's dumb. Price times quantity. Price times quantity minus average cost times quantity. The other way you can do it is you can say, well, it's just going to be equal to price minus average cost times quantity. And you'll get the same answer any of those ways. But let's look at it visually also. So here we have the graph we've developed. I'm going to take the dead weight loss triangle out again. And now we have something new to calculate. Now we want to calculate profits. And profits are going to be this area here that is the quantity we produce, the price we charge, and our average cost. And if you don't remember, our average cost is Q. And so our average cost is all the way down here. And average cost equals Q is 16.67. So our profits for our monopolist are pretty significant. So that's the sort of visual representation. And so the other way with my intro students that we calculate profits is I say find the area of the triangle. But we know what the area of the triangle is. It's the quantity sold and the markup on that quantity, right? The markup over average cost. So what we want to see is what profits are when profits are equal to total revenue minus total cost. So I'm going to do it the way that I'm the most comfortable, which is I'm going to say I want to find price, 66.67, minus average cost, 16.67, which is going to give me 50.3 or 50. And then 50 times Q, which is 16.67, gives me total profits of, drum roll please, $834. And some change, depending on how you round it. Does that make sense? I think if I rounded it differently on my example, but 50 times 16.67 equals, I got 833.5. Close enough. Cool. So let's add that to our board. So now we have that the monopolist's profits are equal to $833.50. Cool? All right, we're chugging through. We are almost done. There is one question left on this homework problem. I told you it covered everything. The last question is, how might the government regulate this market in order to improve welfare? There's a lot of ways, but the easiest way that the government would regulate the market is that they would set price regulations. And they could set the price regulations to be at marginal cost or at average cost. Either one's an acceptable answer. I usually like to set it at marginal cost, or you can set it to the competitive price. Make them act like they're competitive. So reduce their profits to some extent, reduce their control on the market. Other ways that the government has tried to regulate monopolists, break up the firm, try and subsidize competitors, different things like that. There's lots of complicated versions of it. But the short answer is regulate their price and set their price to either the competitive equilibrium or to marginal cost instead of having that markup and having price based on demand. Hopefully that makes sense. Let me know what questions you have. That was the big problem. The rest of these problems are going to fly right by. So that was number 2. I apologize for the discontinuity moment, but I skipped number 3, so I'm going to stick it in right now. Question number 3 asks about the markup. So it gives us a price of $90 and marginal cost of $45. And this is a pretty straightforward problem. What we're looking at here is how much is this monopolist marking price up above marginal cost. And the reason we want to know this ties back to all of our ideas about market power and the Lerner index and price elasticity of demand. And it comes from this idea that the monopolist faces our downward sloping demand curve. And so in perfectly competitive markets, we're going to see a pretty similar, not necessarily different, marginal cost, average cost curves. The difference is, and I know I've been saying this over and over again, but the difference is that in a monopoly, the monopolist sees that downward sloping demand curve and gets a downward sloping marginal revenue curve. Oops. And so the size of the markup is going to be a function of how different price is from that marginal cost point. So how do we find markup? Super easy. Markup is price minus marginal cost divided by price. So in this case, we have 90 minus 45 divided by 90, which should give you 0.5, 50%. So that's telling us, and we could see it, right, because we know math, we could see that. What it's telling us is, in this case, the monopolist has marked price up 50% above marginal cost. And that's a measure of how much market power they have. We could take this and then ask about what the price elasticity of demand is, what the Lerner index is, those kinds of things, because that's going to give us a sense of how much market power this monopolist has. And remember, the market power a monopolist has comes from things like how many close substitutes there are, how far away the substitutes are. So like if we think about gasoline, maybe there's diesel versus conventional, or if we think about, I've made references to medicines, is there a generic available or something like that? Those kinds of things can help erode market power for a monopolist. And so it depends on how close the substitutes are. So that's our markup problem. That's number 3. Sorry for the discontinuity. Thank you guys. Number 4, what are the conditions that create a natural monopoly? What is an example of a natural monopoly? The big difference between a natural monopoly and a true monopoly, or a non-natural monopoly, an unnatural monopoly, is that in a natural monopoly, it makes sense for the market to be monopoly controlled. It's not a situation where it's economically feasible or even preferable, welfare enhancing, to have competition. So in a natural monopoly, we don't have a situation where adding more competition, lowering barriers to entry is going to make it a more better market. So if we think about, I just erased it. If we think about traditional markets, any market that's not a natural monopoly, we're going to see that they're going to tend to look like this, right? They're going to have a generally either a fishhook or an upward sloping marginal cost curve, and what I like to call the smiley face average cost curve, something that goes down and then rises after it crosses average cost. Natural monopolies look totally different. So in a natural monopoly, the average cost curves are shaped more like this. And it's not that they don't eventually come up, it's that they don't come up for so long that it doesn't matter that they come up. So maybe this is like over here at Q equal to 1 million. If individual Q is 1 million when costs start rising, then you need millions of people demanding this good for it to make sense to split that into 2 firms. If total market demand is 1 million, then one firm can handle that 1 million without costs going up. So that's a way to think of it. The basic idea is fixed costs are so high that it takes a long time to average them out. And so average cost curves can behave like this. And we can even see situations where marginal cost is below average cost for a very long time. Not that long, that long. So that's the basic condition for a natural monopoly. Natural monopolies occur when usually fixed costs are very high, but average costs are relatively flat. And there's a lot more nuance to this. We can talk about it more. There are situations where demand changes and natural monopolies evolve into more competitive markets. But generally what you're going to see for a natural monopoly is a relatively flat average cost curve. And that just means that, let's say this is demand here. Where demand falls, costs are still falling. And so if only one firm produces that quantity, costs are relatively low. If we divide that quantity into two and have two firms, all of a sudden costs are going to be way higher than they would have been. 1/2 Q star. If only one firm produced it. And that's the big characteristic of a natural monopoly, is that it's welfare maximizing to have one firm produce the service or the good because of the fixed cost, because of the shape of the average cost curve. Make sense? Hopefully. Natural costs or natural monopolies are usually things like utilities, things like sewer systems, public transportation systems, water, electricity, those kinds of things, where it costs a lot to set it up, to get all the equipment to run things to every household, but then the per unit cost of provision is relatively low. So those are situations where natural monopolies will prevail. Last question, we're almost done. Question 5. Question 5 says, suppose a monopolist has a cost curve of CQ equals 800 minus 15Q. Let's get it up here. And a marginal cost of 15. So we have our cost curve is 800 minus 15Q. So that's going to mean that marginal cost is just 15. Average cost is going to be 800 minus Q, or divided by Q minus 15. And demand is P equals 400 minus 4Q. P equals 400 minus 4Q. Oops. That should have been uppercase Q. What is the marginal revenue? We've done this already, so let's do it one more time. Marginal revenue is going to be 400 minus 8Q. Profit maximizing quantity occurs when marginal revenue is equal to marginal cost. So marginal revenue is 400 minus 8Q equals 15. So 400 minus 15 is 385 equals 8Q. 385 divided by 8 is 48.125 equals Q star for our monopolist. What price will the monopolist charge? Find that out. We just go ahead and stick this back into here. So let's change colors again for the next part. We want to find P star is going to be 400 minus 4 times 48.125, which is going to be equal to 400 minus 4 times 185, or 4 times 48.125 is going to be 192.5, or a price of $270 or $207, sorry. It's getting late. Price is going to be $207.50. So marginal revenue comes from the inverse demand function. Marginal cost comes from the cost function. Set them equal to get Q star. Insert Q star back into market demand to get our price. And then the last part is if regulators were to set the price to a competitive equilibrium, what price would it be? We know this. They could set it to either marginal cost or to the competitive price equilibrium. If they're going to set it to the competitive price equilibrium, then all we need to do is set demand equal to marginal cost to get the competitive equilibrium price. So that's going to be demand equals marginal cost, which is P equals 400 minus 4Q equals 15. 400 minus 15 is 385 equals 4Q. 385 divided by 4 is going to give us Q equal to 96.25. And so that would be our competitive Q star. And then we insert it back into the demand function to get our competitive price. So now we have P star, instead of the monopolist, the competitive is going to be 400 minus 4 times 96.25. I'm running out of room, so we better be done soon. 4 times 96.25 equals 385. 400 minus 385 gives us a competitive price of $15. Cool? Makes sense? Hopefully that makes sense. Let me know what questions you have. Let me know if you have any issues with anything we said here, if there's anything you'd like me to do over again. Otherwise, that is your answer key for assignment 9 for intermediate micro. Thank you so much. Have a great day.